All right. So the topic that I'm going to start now is nowhere included in your school exams. That is totally based on JEE Mains and JEE Advance. All right. So one of the topics is, first of all, let's talk about some triple product. Triple product. See, if I talk about three vectors, okay, now A dot B vector C. I write an expression like this, then A dot B dot C, then A dot B cross C, then A cross B dot C, A cross B vector C, and A cross B cross C. I write these six expressions. All right. So first of all, tell me, is it of some significance A dot B dot C? Definitely not. Because once you have done A dot B, now this A dot B became a scalar. Now a scalar and a vector, vector C, you cannot do their dot product. Am I clear? Now similarly, if I go with this is also not significance because once you do A dot B is a scalar and a vector C, they cannot be cross multiplied. Am I clear? Now if I go with this, you can see A cross B. A cross B will be a vector. But this vector A cross B and vector C, what about them? Neither the dot mentioned in between nor cross mentioned in between. So this is also not significant. Now this is what? This is totally fine. A dot B is a scalar and then you are simply multiplying a scalar with vector C. It does not further involve any dot or any cross product. Got it? Now come to this. A cross B is a vector and that vector is multiplied with vector C in the dot product manner. So this is what we call scalar triple product. Now if I go with this. Now A cross B is a vector and that vector is further cross multiplied with another vector C. So this is what? Vector triple product. Why do we call it scalar triple product? Because the resultant will be scalar. A resultant will be scalar. And here, a resultant will be a vector. So first one is resultant will be a scalar. That is why we call it scalar triple product. Second one is resultant will be a vector. That is why we call it vector triple product. Now we will start with scalar triple product. Scalar triple product. See, this A cross B dot C. This is what we call scalar triple product. Now there is another way to write it, that is box A, B, C. This is a way to write it. You do not separate any comma in between, just write ABC at some gap and make it in a box. And that is why we also call it box product. Got it? Now, what is this box ABC? Box ABC is A cross B dot C. Now, A cross B is magnitude of A, magnitude of B sine theta, where theta is what? Theta is angle between A and B, into vector N dot vector C. Am I clear? So it is magnitude A, magnitude B. Now see, further you take this dot product. N is already perpendicular to A and B. And now let us assume phi is angle between vector C and n cap. So mod A, mod B, mod C, magnitude of n cap is 1 into sine theta cos phi. Am I clear? So this is what it is, box A, B, C. Magnitude A, magnitude B, magnitude C, sine theta cos phi. Got it? Now see, there is a structure called parallelepiped. Parallelepiped. Parallelepiped is what? It is kind of a like tilted cuboid, I should say. A cuboid has been tilted. Like this is a parallelogram. Again, there is another parallelogram. Then you join its vertices. If you can imagine this figure in 3D, this is what we call parallelepiped. Got it? Now let us assume here it is x-axis. Here it is, say y-axis. Got it? And somewhere there will be z-axis. This is how it is. I hope you can imagine like how tilted it is. Got it? Now see, we were talking about box ABC a while back. That is A cross B dot C. Now, if I write it magnitude A, magnitude B, sine theta n cap dot C. Now see, let us assume this is A, this is B, and this is C. Got it? So this AB sine theta is what? Area of base. Area of base. If this base is in XZ plane, now this along the y-axis n cap will exist. Now C sine C dot n cap is what? Projection of C on normal vector. Projection of C on n cap. And this is what we call height of prism. This is a prism kind of. So that means this box ABC is what? It is volume of the parallelepiped. Volume of the parallelepiped with coterminous edges along and C. Am I clear? Yashwant, you got that? Vedant? Very good. So this box ABC is what? Volume of parallelepiped with coterminous edges along A, B, and C. Got it? Now, see. In any case, if this box ABC goes 0. All right. So in any case, in any case, this box ABC goes 0. Then what will happen? That means this parallelepiped does not exist, means its volume is 0. So if it is so, that means this parallelepiped does not exist. So if the parallelepiped does not exist, if the parallelepiped does not exist, means what? A, B, and C are coplanar, or any one of A, B, or C is 0. Am I clear? So if this is getting 0, that means what? Box A, vector A, vector B, or vector C is 0. That means either one of A, B, C is which is highly unlikely. Why would any vector be 0? Alright. So in that case, A, B, C are coplanar. Its vice versa is also true if A, B, C are non-zero vectors. If A, B, C are non-zero vectors, then box ABC will be 0 if A, B, and C are coplanar. If A, B, C are coplanar. Alright. Another thing, box I cap, J cap, K cap. What it should be? I cap, J cap, K cap, each of magnitude 1. They will be the coterminous edges of, a what? Coterminous edges of a cube. So volume of this will be what? 1. Cube with side length 1. 1. Now, if let us assume A is A1 I cap plus A2 J cap plus A3 K cap. B is B1 I cap plus B2 J cap plus B3 K cap. And C is C1 I cap plus C2 J cap plus C3 K cap. All right. A is A1 I cap plus A2 J cap plus A3 K cap. B is B1, B2, B3, C is C1, C2, C3. Then box ABC will be determinant A1, A2, A3, B1, B2, B3, C1, C2, C3. Am I clear? So this is how you can calculate box ABC for any three vectors as determinant of A1, A2, A3, B1, B2, B3, C1, C2, C3. Now see, if any of the two vectors A, B, or C are parallel, means linearly dependent. So out of these three ABC, if any two goes parallel or linearly dependent, that means any two rows of the determinant will be identical. And if the two rows of the determinant will be identical, in that case, box ABC goes 0. Got it? In that case, box ABC is 0. Next, see this box ABC is box BCA is equals to box CAB is equals to box. See, if ABC follow the certain order, if A, B and C, they follow the certain order, that means their value does not change if we reshuffle that. But yes, if you break that monotonicity, so ACB if you do, so value will be negative of that. Am I clear? Value will be negative of that. Next, position of dot and cross can be interchanged. Means box ABC, you can write it A dot B cross C, or you can also write it A cross B dot C. So however you do it, it will always give you as volume of the parallelogram. All right. Next, say you have K vector A, mu vector B, lambda vector C. That means, see in this determinant, that means first row is multiplied by K, second is multiplied by lambda, and this is multiplied by mu, or whatever it is. So you can take that common outside. So this is also equals to K mu lambda box ABC. This is also equal to K mu lambda box ABC. All right. Am I clear? Now, another thing. Unknown caller. Box A plus B, B plus C, C plus A. This is equals to twice of box A, B, C. Got it? Now, how? See, A plus B, B plus C, C plus A box. This can be written as A plus B dot B plus C cross C plus A. So first of all, what I'm going to do, I'm going to do the cross product. So it is B cross C plus B cross A plus C cross C will go 0, and finally C cross A. Now there is a dot product in between. Now see, first this A will multiply it by this, so it will become A dot B cross C. Then this A multiplied by B cross A 0, because if two vectors are identical, value goes 0. A dot C cross A 0, then B dot B cross C 0, B dot B cross A 0, and then B dot C cross A. C cross A. So this is what? Box ABC. This is also like order changed, but same BCA. So that is also box ABC. So answer goes twice of box ABC. Have a look. Quickly see. Got it? Now, another very simple rule. Box A minus B, B minus C, C minus A. This will always be 0. For irrespective of any ABC, box A minus B, B minus C, C minus A will always be 0. That means even if ABC are coplanar or not coplanar, A minus B, B minus C, C minus A will always be coplanar. Got it? Now, a very, very important property. box ABC square. This is what? This is box ABC multiplied by box ABC. What is box ABC? A1, A2, A3, B1, B2, B3, C1, C2, C3 multiplied by another box ABC. इसको I write like this: A1, A2, A3, B1, B2, B3 and C1, C2, C3. Got it? Now if you multiply both of them, see A1, A2, A3 multiplied by this. So A1, A1 plus A2, A2 plus A3, A3. So this is what? This is A dot A. Correct? Now you multiply this with this thing. This will be what? A dot B. Then A dot C. Then B dot A. B dot B. B dot C. And then C dot A. C dot B. C dot C. Got it? So this is actually important. Okay, one more thing to remember this. Have a look. Am I clear? Now, volume of tetrahedron. With coterminous edges along A, B, and C. 1/6 of box A, B, C. Got it? Okay, everyone. Quickly see this. Okay? I shall be back in a moment. You just do that. And if you have any concern, keep me posted in the chat box quickly. Hello? Yes. So this was vector triple product. All right. The most important thing here is how to calculate the volume of a tetrahedron. That is 1/6 of box ABC. How to calculate the volume of parallelepiped. That is box ABC. and how to calculate box ABC is from this. Just simply put the vectors in the determinant and get the value. Am I clear? Now there is a theorem, simple theorem, to which we call theorem in plane. Theorem in plane. All right. So the theorem says if A and B are two non-zero, non-collinear vectors, if A and B are two non-zero, non-collinear vectors, then any vector C in the plane of A and B can be expressed in the linear combination of A and B. So if A and B are two non-zero, non-collinear vectors, then any vector C can be expressed in the as a linear combination of A and B if this C is coplanar with A and B. That means C can be written as x vector A plus y vector B. When if ABC are coplanar means if box ABC is 0. Got it? So if box ABC is 0, so any vector can be written as a linear combination of the other two vectors. Am I clear? Now, there I comes with the vector triple product. Vector triple product. Now see, what does this say in vector triple product? It is in the form of two vectors A cross B cross C, or V is A cross B cross C. So one is A cross B cross C, other is A cross B cross C. Now see one thing. Just a moment, I will stop my screen. Now see. Now see, let us assume there are these two vectors. All right. There are these two vectors. Now, if you take their cross product, you will get a vector which is perpendicular to both of them. Let us assume these are two vectors. So if I take their cross product, I will get this vector which is perpendicular to both of them. Yes or no? Now, this vector is being cross product with another vector, vector C. If this vector is being cross product with another vector, you will get another perpendicular vector. So this another perpendicular vector will be parallel to these two initial vectors. Am I clear? So it is like this, that this vector will be perpendicular to C, but in the plane of A and B. Am I clear? Whereas Whereas this vector, this will be perpendicular to A, but in the plane of B and C. Is it fine? So first vector will be perpendicular to C and in the plane of A and B. So it will be linearly dependent on A and B. Second vector is perpendicular to A and in the plane of B and C. So it will be linearly dependent on B and C. Now I'll directly write their formulas. Here this expansion is these distant ones. A dot C vector B minus B dot C vector A. And this vector is A dot C vector B, again these distant ones, minus A dot B vector C. So this formula you have to remember. So distant ones multiplied by B minus near ones multiplied by A. Here also distant ones multiplied by B minus near ones multiplied by C. Am I clear? Have a look. Got it? So these formulas you have to remember. I'm not going into their proofs, but formulas are there. You have to remember. Like a simple question will do. For three vectors, A is I cap plus j cap minus k cap. B is 2I cap minus j cap plus 3k cap. And C is minus I cap plus 2j cap plus k cap. Now they are asking you, find a unit vector. Find a unit vector in the plane of A and B and perpendicular to C. Find a unit vector in the plane of A and B and perpendicular to C. First of all, how do we do it? See. Madhukar, Bhagat, Bhagat, यशवंत Bhagat, switch on your mic.
Sir.
Bhagat, how do we do it? Unit vector in the plane of A and B and perpendicular to C.
You need to write the determinants.
Sorry?
You need to find the magnitude.
Magnitude we'll find later on, but which vector is there which is in the plane of A and B and perpendicular to C? Tell me. See, A cross B cross C. A cross B cross C. This will be a vector. A cross B cross C. This will be a vector perpendicular to A and B and in the plane of C. Yes or no? and this is what? A dot C vector B minus B dot C vector A. Now A dot C goes what? Minus 1 plus 2 minus 1. Vector B. B is what? 2I cap minus J cap plus 3K cap minus B dot C. B dot C is what? Minus 2 plus 3 into vector A, that is I cap plus J cap minus K cap. So this value goes 0. That is okay. So this is going to be my answer. So that is minus 4 plus 3 minus 1 1. So it is 1 time I cap plus J cap minus K cap, isn't it? Now this is a vector. They are asking for unit vector. So unit vector will be what? Unit vector will be I cap plus J cap minus K cap divided by its magnitude, which is under root 3. And then take a plus minus sign because it can be above the plane or it can be below the plane. Yes or no? Am I clear? Now, there is another very important result that you will remember, that is box A cross B, B cross C, C cross A. Scalar triple product of these three vectors, this is equals to box ABC whole square. इसको you try to prove it later on. A cross B plus B cross C plus C cross A is equals to box ABC whole square. All right. Okay. Now try this question. C be a vector perpendicular to A and B and C dot this is 8. Then find the value of C dot A cross B. Attempt it quickly. C be a vector perpendicular to A and B and C dot I cap plus J cap plus 3K cap is 8. Find the value of C. Calculate C and give me your answer in chat box. Yes, quickly. Now see how easy it is. First of all, C is a vector perpendicular to A and B. If C is perpendicular to A and B, that means C will be some lambda times A cross B. Because A cross B is a vector which is perpendicular to both A and B. So if you calculate A cross B, which you are already aware of, I cap, J cap, K cap, 1, 1 minus 1, 1, 2, 1. So that would be will I cap 2 minus J cap again 2. With K cap it is 1. So it is 2I cap minus 2J cap plus K cap. So C को I can write, it is lambda times 2I cap minus 2J cap plus K cap. Another thing they gave you that C dot I cap plus J cap plus 3K cap is 8. Students, am I audible? Just give me a cross check if I am audible or not. Please tell me if I am audible or not. Thank you. Actually, the power went off. So that is why. So C dot I cap plus J cap plus 3K cap is 8. Lambda times 2I cap minus 2J cap plus K cap dot I cap plus J cap plus 3K cap is 8. So it is 2 minus 2 plus 3 is 8. So this implies your lambda is what? Lambda is 8 upon 3. Got it? So once you got lambda, you got C. So C is what? 8 upon 3 times 2I cap minus 2J cap plus K cap. Now what you need to do? C dot A cross B. So C dot A cross B you have to calculate. That is box of ABC. So 8 by 3 times C is 2 minus 2 1. A is 1 1 minus 1 and B is 1 2 1. This will be your box ABC. Am I clear? All right, we'll practice more questions in the coming session. That would be all from my side for today. So just please fill this form.